Okay, for this problem we're going to use mathematical induction to show that this sum here for these n terms is equal to n over n plus 1. Now the way we're going to do that, we start with the n equals 1 term. So proof is going to be induction on n. Now that's obvious because the problem tells us to use mathematical induction. But it's a good technique to put down at the start of the proof the technique that's going to be used. Okay, n equals 1 step. So there's my base case, n equals 1. On the left hand side it's just going to be one term only, and that'll be the first term, 1 over 1 times 2. And on the right side, if I replace n by 1, I'll have 1 over 1 plus 1. And that is true. 1 over 2 equals 1 over 2. So the n equals 1 case checks. Next, n equals k. We'll assume that, and again for n equals k, everywhere I see an n, I now replace by k. So 1 over 1 times 2 plus 1 over 2 times 3, all the way through 1 over k times k plus 1. We'll assume that's equal to k over k plus 1. So that's our induction hypothesis. And now the real work begins, n equals k plus 1. I start with the left-hand side. Now the left-hand side will now have one extra term, and so I'll list out the k terms that I have already, and then I list out the next term that appears. And I know this is the next term because if I replace n by k plus 1, I would have k plus 1, which matches the k plus 1 here. Then k plus 1 is the k plus 2 that we see here. Now my target that I want to end with is what I get if I replace n by k plus 1 over here on the right hand side. And so that will be, my target will be equal to k plus 1 over k plus 2. So k plus 1 over k plus 1 plus 1 gives me k plus 1 over k plus 2. And that's my target. Now somehow I need to turn this into this, and I'm done. Now to get started, I'll use the induction hypothesis. These first few terms without the extra term is equal to this by assumption. So k over k plus 1. And this extra term simply comes along for the ride. 1 over k plus 1 times k plus 2. Okay, now let's get a common denominator. So k plus 1 times k plus 2. And what's going to be left on top is going to be, if I multiply top and bottom by k plus 2, I get k squared plus 2k. Multiplying this by k plus 2, and also multiplying this by k plus 2. Then I have an extra plus 1 from over here. So that's equal to k plus 1 squared over k plus 1 times k plus 2. And that matches my target, because when I cancel the square here and the k plus 1 here, that ends up with k plus 1 over k plus 2. And so I didn't write it down here. This is by induction hypothesis. And I want to explicitly mark the step where the n equals k assumption gets used. Okay, so that ends the proof, and so I can use any standard end of proof symbol. I'll use QED for this one to denote that I've reached the end of the proof, that I've successfully turned the left-hand side into my target on the right-hand side, and I'm done.